Hello YouTube, this is Jay Coder back with another stream. Today we're going to be going over an article I have here. It's over classes and inheritance, and I hope that this will be able to help you guys to internalize more of the concepts of the inheritance and classes, whether you be a beginner or someone who just needs a quick refresher, and I'm using imagery here to help you learn and internalize a bit better. So without further ado, let's go ahead and get started. I'm going to go ahead and I have a Kotlin playground here where I'm going to be going over the Kotlin code and the material I want to go over in the article. So I have this article here on Medium, Kotlin classes and inheritance, a family drama. And in here, we're going to be going over classes. It's going to be kind of a more lighthearted and funny kind of imagery way of going over this to help with the memorization of the concepts. So, so what we have here is in the introduction, it says, "Welcome to the Kotlin family, where inheritance isn't about old family heirlooms, but about sharing code, just like in a family where traits and characteristics are passed down from parents to children. In Kotlin, classes inherit properties and functions from other classes. So when you think of classes and inheritance, you can think about a family structure. So there's the super classes and the child classes, and the most simplest terms. So you can have a structure like this, such as the head of the family, the superclass, and in Kotlin, the superclass is the head of the family. Think of it as the great grandparent who features you can't escape. This class holds the common attributes and behaviors that the subclasses or the children and grandchildren in our family drama will inherit. So I also copy this over here to the Kotlin playground. And so basically, the example we're illustrating here is this is a superclass, and we're declaring it. Of course, it's going to be outside our main function here. And so we declare our class, and so we have a value of Kotlin string, and then we have a method in this class that will display the family name. In this case, we're setting the family name to Kotlin. And so this is our superclass. So it's going to have the word open, meaning that there can indeed be a subclass where this means the subclass can inherit the traits from this class. By default, if you do not use the open, then in Kotlin, you cannot inherit from the superclass because it will give you a error. But in this case, since we have the open, we can indeed have children that inherit from superclass. So in this case, we have the superclass 1 and superclass 2. So basically, hypothetically, we have two children from this superclass that is Alice and Bob. So basically, when we declare classes, we can go ahead and call it inside our code. So we want to execute the class code within our main function here. So basically when you want to execute code inside your main function, we need to declare a variable such as the actual class that we want to show. So I can go ahead and call this child one, and this child one is going to be this subclass. So subclass subclass one, and then you need the constructor here, which is the constructor is what is passed into the class. In this case, we don't have anything being passed in here, so uh, so we don't need to pass a variable here. So in order to declare that, I can do that. So we have the child one, right? And so since we have the child one, um, we can say, so what is child? We can say child one dot display family name. And so child one dot display family name. See what that gives us. Conflicting. Okay, I also have a main down here. Let me go ahead and delete that real quick. And so let's go ahead and play that. And so here, child one dot display name, family name. Since we do, let's try that. And then, all right. So since we are inheriting from this superclass, I can use this method called family name. So the family name is indeed Kotlin. And you notice that, of course, I don't have to um, re-declare the method down here. I can just use the method that was already used in the class. And so right now we have a variable within there with it, which is the first name. And so the family name is that. And so I want to list the first name. So child. So we can say child one name is, then we can go ahead and take this guy, put it here, and it's going to be, we're gonna put the template here, the which is with the dollar sign, and then we're going to say dot first name. So we can have this like that. And then child one name is child one dot first name is, see here, unfind reference. So this is spelled wrong. This needs to be capital. And when I go ahead and play it, it will display the family name is Kotlin, child one name is Alice, and also we do have a child number two here. Uh, which what do you all think will happen if we go ahead and make, or I'm sorry, make a subclass to make her a subclass, well, this person a subclass 2, and then we want to go ahead and use this to display our child 2, and then when we display our, or I'm sorry, this is going to be also child 2. So child 2, let's see what that does. So child 2 is Bob, child 1 is Alice, and what do you think the family name is going to be since they both inherit from the same parent? So basically, if I, you know, call this and do the same thing, they're both going to have the same family name because they inherit from the same parent. So basically, the family name for both is Kotlin. So, so yeah, that's what I wanted to demonstrate for this first part and the second part. So, subclasses in Kotlin are like eager children inheriting features from the superclass. They can call all the traits of the superclass and add some of their own, like adding funky hairstyles to a traditional family look. Overriding family overriding family rebellion. So there's a concept called overriding in Kotlin, and so it says sometimes subclasses want to do things their way, and here comes the concept of overriding. It is like when teenagers dye their hair purple despite their parents' natural brown hair gene. Kotlin subclasses can override methods of the superclass to behave differently. So basically, I have that example here as well, whereas about the overriding. So I'm going to go ahead and delete these things here that I just got done demonstrating. And then, so we have an example of the overriding here. So we have a class called parent. We have this open because we are allowing the class to inherit, and this child inherits from this parent, and thus the child uh we could say like rebel child equals, and then actually the the class name is going to be child. So this equals child of the class name. We're not passing anything in there, so that's fine. And then they both have a method called, so right here is the example where they both have a method called hobby. So what the emphasis is this child um, can inherit the hobby of the parent or override its own hobby. So actually, let me go ahead and comment this out really quick, and then let's call hobby on the child and see what happens. So basically, we can use this child rebel child dot hobby, and then when we play that, all right, it's gonna say parent loves gardening. So basically, it continues on with the inherited hobby. Parent loves gardening. Um, and then so basically, in this example, we can go ahead and like if you want to change what the child wants to say for the hobby, you can change it here. So basically, now let's see after commenting that out, after re adding this code, what do you think is going to happen when we call the hobby function here? So we don't have to change anything, and let's see what happens. And so we played it, and it says child loves code. So basically, when you use override, when you so basically when you use the override, that means that you can have a method of the same name but do a different functionality, or you can use what was defaultly inherited from the parent for that particular function. So that was my demonstration for that one. And then number 4, the abstract class, the mysterious uncle. In the Kotlin family, there's always that one mysterious uncle who only tells you what to do but never how to do it. That's your abstract class. It declares methods but doesn't define them, leaving the specifics to its subclass. So basically, in the example over here, is we're going to use abstract. So I'm going to delete that previous example here. And then I'm going to go down to the mysterious uncle, which is going to be abstract. So what abstract means is that unlike what was here with the parent, where we had the method and the method implementation, with abstract, we only have the actual method name and no implementation to inherit by default. So with this abstract, it means that basically you have this method of get advice, and then it's going to be up to the child class to implement that advice. So this give advice, um, this mysterious uncle says we have this method called give advice. So inside the actual nephew, um, the nephew will have to interpret the advice for themselves. So it says always use Kotlin for Android development, which is the actual advice. So let's go ahead and see what happens when we try to use this particular code. So let's make a new class from the nephew. So we can say val new nephew equals, and this is going to be from the class nephew, which inherits from mysterious uncle. So this is going to be the class nephew. And then what we're going to do is, so the nephew is going to try to use the method. So the method is get advice. And let's see what happens there. So, all right, it does use what it overrode the method to have. Um, so the mysterious uncle did indeed, um, well, the nephew did indeed uh, implement what was given from the method implementation of from the mysterious uncle. But let's go ahead and let's temporarily get rid of this and see what happens. So it gives an error. It says nephew is not abstract and does not implement abstract base class member public abstract function give advice unit defined in mysterious uncle. So that means it's not an optional thing to to implement this method. It's a required thing. So if you inherit from an abstract class, you must implement the method that is inherited from the mysterious uncle. And so that's what I wanted to demonstrate from the abstract. And then 5 interfaces, the family advisor. Interfaces in Kotlin are like the family advisor. They are not part of the direct lineage, but provide guidance and rules, methods that anyone in the family classes can adopt. So, all right, and here's an example of how an interface is used. So, well, actually, I have it over here. I'm going to go ahead and delete this code uh, example there. And then we're going to go down here to the interfaces, the family advisor. So basically, it's very similar to the abstract class, and it gives the method to implement in the class that inherits from the interface. So you use the same syntax to inherit from an interface, which you would also use for a class where you would use this colon in Kotlin to go ahead and inherit from this interface. And so now we're implementing this interface, and it now I'm curious. What if what will happen? Well, actually, let's go ahead and make this cousin here, this cousin class really quick. So we're gonna say like cousin Bob equals cousin, and so this is gonna be our cousin Bob, and then we inherited that method from the advisor, cousin Bob dot, and so we inherited the give guidance method, and so we say that here, and then when we go ahead and play that for the give guidance for the for this guy, let's go ahead and play that. Says class nephew is not. Oh, for the nephew, I didn't fix that where I deleted that temporarily. So so basically, it's the override fun give advice, and well, this is for the last example, but I would, of course, need this to make it work. And then print whatever vice goes here. Okay, so let me go ahead and fix that. So says remember to use inheritance wisely, and that was from the family advisor that cousin inherited from. And so yeah. Now, basically, it functions the same way um, with the abstract class and also the interface. So let me go ahead and I want to delete the override and see what will happen here. So so when you don't have an override, it will say give guidance highest member of super type family advisor and needs override modifier. So when you are inheriting, you must have the override keyword in order to implement the function from the parent. So, all right, so that's great. So, one thing about interfaces, they are not a direct lineage of the actual family, but they can kind of be used anywhere in the family if the family wants to take advice from the advisor, which is the interface. So, all right. As in conclusion, happy Kotlin family. Inheritance in Kotlin, much like in a family, is all about sharing, adapting, and sometimes rebelling. Understanding these concepts is like uncovering the dynamic of complex code-based family tree. So embrace your Kotlin inheritance, and maybe just maybe you'll find your code resembling a quirky yet functional family drama. So yeah, so basically that's going over inheritance in classes. And as you can see, you can also um, put in variables. Uh, you can pass in variables also into the constructors here if you allow that for setting the default values. But that's what I wanted to show you guys today. So there's also in the same article a bonus section, and you I'll let you guys go ahead and take a look at that and see what that is, because I'm gonna go ahead and include this link in the video. Like a sneak peek is going to be going over data classes, sealed classes, inline classes, more about more about the open keyword, and I'll include that link in the bio. But if you guys like this kind of stuff, learning more about Kotlin and going over refreshers over things like classes and other key Kotlin concepts, go ahead and like this. Go ahead and subscribe to this channel, like this video, comment on this video, and as always, stay coding. Have an excellent day. Peace.